What we're going to look at today is constructing a box plot, okay, or a box and whisker plot. How many of you have ever dealt with these before? Okay.
Exclusively for the FCAT.
Okay. How many of you, so, none of you have ever actually made them yourself?
Just Michael.
Okay. Did you actually make any? Or did you just interpret them?
No, I had to make them.
Okay.
I don't remember, like, it was
Okay.
just past the FCAT.
Well, that's okay. So, here's the deal. There's going to be quite a few terms here. So guys, make sure that you are focusing and you are writing down what these terms actually represent. Okay, because, you know, if I ask you for a 5-number summary, or what the IQR is, you got to know what those mean in order to answer the question, okay? So, you know, make sure you pay specific attention to the terms that are involved, okay? The first term is actually a really simple one, but it's the range, okay? The range of our data is just the distance between the max and the min. Okay, so you take the max score and subtract the min score, and that gives you your range. So that's pretty simple. But then we have what are known as quartiles and IQR. Okay, what we're talking about, just to give you a summary of this whole concept here, and part of the reason why we're looking at the range is we're going to be looking at the distribution of our data, or the spread of our data, but instead of looking at it in relation to the mean and standard deviation, what a box plot does is it looks at the spread of data in relation to the median. Okay, and as we saw earlier, for different data, the median can be a better representation. Okay? So let's discuss what quartiles are and then what the IQR is, okay? The first quartile, which we'll use Q1 to represent, it's the value that is greater than 25% of the data. Okay, quartile, quarts, all right, it's a quarter of the data. All right?
Quarter.
So it's a quartile, greater than 25%. Now, what does this mean? Or how do we find this quartile? I told you that this was all related back to the median. Well, the quartile is the median between the min and the median of all of the data. Okay? So the first thing we're going to be doing is finding the median, which, if you think in terms of quartiles, the median would be greater than how much of the data? 50%. So another word for the median is actually the second quartile. We never call it that, but it wouldn't be wrong to call it that. Okay? But the first quartile is the median between the min and the median. Alright, so that's the 25% mark. Then the median is your second quartile. It's greater than 50% of the data. And then what do you think the third quartile is?
75.
It's the 75% mark, okay?
I remember.
It's the value that's it's greater than 75% of the data. Okay? Now, how do you think we find the third quartile?
Take the median of the data from median
The median to the max.
Yeah, take the median of the data going from the median to the max. Okay? Now, so we have our 3 quartiles here. If you really want to call the max the fourth quartile, it's the highest value, so it's greater than 100% of the data. We have our 3 main quartiles here, though, but that leaves us with this last term here, the IQR. okay? The IQR is what's known as the interquartile range, okay? The interquartile range, IQR. It's the range between the first and the third quartiles. We said range was the distance between the min and the max. The IQR is the distance from the first quartile to the third quartile. So we subtract those two values. Inter means between or within, okay? So it's the range within the quartiles, or between the quartiles. So, you say, okay, well that's nice. How does this all relate to a box plot or a box and whisker plot? How would we make these? Well, for a box plot, you need 5 values, okay? 5 key values. And to make a box plot, you're going to first of all come up with the 5-number summary. Alright, so if you're asked for the 5-number summary, these are the 5 values you want. Your minimum value, your lower quartile or first quartile, your median, your upper or third quartile, and then the max. 5 that really construct our box and whisker plot. The IQR we'll talk about later. We will use that in some cases. We'll use it in all of them, but in some cases that'll affect our actual box plot. We'll see that later. So let's look at a box plot and see how all of these come into play. Alright? So you'll notice if we use these 5 points, okay, here's our 5-point summary that we found from the data, okay? So what you would do is you have a number line going below your box and whisker plot, okay? You need to mark your minimum point, mark your max point, okay, with just points. Those are going to be the ends of the whiskers, okay? The first and third quartiles and the medians are what help us construct our box, okay? The first quartile is the left side of the box, so in this case it was 4. The 9.5 is our third quartile, that's the right-hand side of the box. And then the median, we also mark like this, and that's going to be a segment inside the box. You draw your box connecting the first and third quartiles, and then you can see your median inside it. Alright? Yes?
So, would it make sense to have, like, is this only for lists, or can you do, like, frequencies with this one too? Like the sibling problem we did, would it make sense to use? Like,
If you have frequencies, you could figure out what all these are. You know, for instance, if you had, you know, your x's and your frequencies, and you had, we'll just keep it simple. You know, 1, 2, 3. Well, no, that's too simple. 1, 2, 3, 4, 5. Okay, and let's say we had 4 of these, and 6 of these, and 2 of these, and 7 of these, and 3 of these. Okay, so we have 12 items total. So halfway between the 6th and 7th would be our median. All right. So the 6th and 7th are both a 2, so your median would be 2. okay, then you would say, alright, well, halfway between the 6th and the 7th, that was a 6.5, so I have the first 6 are on that bottom 25%. What's the median of those? So you'd have to kind of see it. Here's these 4 1s and then 2 of the 2s are on that bottom 25%. So that lower quartile would be a 1. Okay? And this data isn't the greatest to do this with, but you get the idea. You can do it with frequencies. Alright, so we plotted our minimum point, our maximum point, we constructed the box, then you simply draw the whiskers out to the min and up to the max points. Okay? Yes?
We know the median is 1 and the max is 15. So the median point should be the 7. If the 1 to the 15 have 14 numbers and the median is 7.
Well, no. I mean, that's possible. We were just given what this is. We don't know what all the scores are in the middle. There might be, here's the thing, there might be scores, all over here. We know there's a score here, we know there's a score here, and there's probably a score at 4, 6, and 9.5. Okay, but there are a bunch of other scores in here that we don't know. But these are the different medians.
Okay.
Okay? Now, a couple of details to remember, alright? Between the first quartile and the third quartile, how many of our scores are in that range?
No.
50%, okay? This is the bottom 25. These are the bottom 25%, okay? This is the middle 50%. And then this up here is the top 25%. Okay?
Is this what they use in college, like in college admission statistics? Because
It's possible. I mean, they could. They could. I guess they could take, like, the SAT scores of all the people that applied and construct this, and okay, we're gonna just automatically eliminate the bottom 25%. We're gonna take all of the top 25%, and then we're gonna look closer at the middle.
they
50.
usually like, if you look up the statistics for students in unit, you usually get the middle 50%, and like you never get the bottom 25, top 25, but like.
Oh, they actually tell
Yeah.
you what the middle is?
Yeah, because the top values, you're not that most likely, so they never tell you that. And the
Okay.
bottom values didn't get accepted, so
Yeah.
you always look at the middle.
Yeah. And that is where most of the scores are. That's where half of the scores are, right there in the middle. So that gives you a good idea of, if you look at their college, at their acceptance rates, and you're in that 50% range, or even near the top end of that, then you at least have a chance, So. Alright, so the box represents the middle half, or the middle 50% of the data. The lower whisker is the lowest 25%, and the upper whisker is the top 25%, like we just said. Okay? So that's how we would construct it. Now, finding these is kind of the next challenge, alright? Once you get them, it's not too hard to draw it. It's just making sure you get the right ones, okay? So let's take a few minutes here and kind of walk through this one, and then I'm going to give you one to try on your own here, okay? So first of all, we're asked to find the 5-number summary and the IQR for the data below. And then we're going to use that to draw a box plot. Okay? So, We already put the data in order from lowest to smallest. There's 2, 4, 6, 8, 9. Okay, there are 9 entries here. So which score is our median?
5. Oh, no.
The fifth score. Okay, the fifth score. So 1, 2, 3, 4, 5. 87 is our median. Okay.
84 is your first score.
Okay.
83.
Well, hang on. Our min is 78. Our max is 98. All right. When you're getting your lower quartiles and your upper quartiles, okay, make sure you're finding the median of just the lower half, okay? So what would the median of those 4 values be? 83 and a half, okay? There's your quartile 1, 83 and a half. Okay? Then, what's the median of your upper half?
95.
95 and a half. Okay? Now, depending on what you look at, okay, there are some cases where they will actually use the 87 and they would say that 84 is the lower quartile. Okay? And they would use the 87 in finding the upper quartile, and they'd say that 94 is the upper quartile. Okay? Alright? For us, we're only going to look at these. Okay? The exception would be if we had an even number of things. Let's say we had a 99 up here, and your median is between these two. Okay? If we had a 10th item here and the median was between them, then we would look at all of these scores below the median. Okay? And we would look at all of these scores above the median because the median was in between 2 of our scores. Alright? But in our case, since the median is 87, we're going to find the median of just those bottom scores and just the top scores. Okay? What's our IQR, interquartile range? 12. We take the 95 and a half minus the 83 and a half, and we get 12. Alright, good. So, here we start to draw ourselves a number line. Okay? I'm going to draw a number line down here. The number line is important because you don't want to label the numbers up in your box plot. You want those numbers to be down below. Another thing with the number line is it doesn't have to start at 0. Just make it appropriate for your data. So when I'm drawing them, I'll usually put, my min down here at one end. There's 78. And here's 98. And then I'll come up with a scale that's appropriate, okay? There's a 20, the range here is 20. So I would probably, go by 2s or something. So there's 80, 82, 84, 86, 88, 90, 92, 94, 96, 98. Okay, I put them a little close together. There we go. Okay? So there's going to be our box plot. And since this is the min, I'll put a point here. Okay, there's my min. Here's my max. Okay. My first quartile is at 83 and a half, so here's 82, 84, so it's just to the left. Alright, so I'm going to go with a vertical line there. Okay. Actually, not have it go through my number line. Okay. So there's that 83 and a half. Then you have, you can label it. Then you have your median, which is at 87, so 82, 84, 86, 87 is right there. Alright, so I'm going to draw that vertical line. Okay? And then my third quartile is at 95.5, so here's 98, 96, 95.5 is right there, approximately. So I'm going to draw a vertical line up this way. Now I can draw my box and my whiskers. Okay? Doesn't have to be a work of art, but you know, you can make adjustments. Alright?
What is the point of these? Like, how do they?
You can actually do a lot of analysis just by looking at this. You know, for example, with this one, notice our whiskers aren't real long. So we know that our middle 50%, you know, is kind of grouped together. Our top 25% is in a very small group. Okay. Also, we'll talk about this a little bit later here, but data can be skewed. And we'll look at seeing skewed. This is a relatively even distribution across, you know, one whisker isn't super long. You know, your median is somewhat near the middle of your box. You know, this is somewhat evenly distributed across the range. Whereas it's possible to have one where, like, you know, you have a really short whisker here, you've got this, and then you have a really long whisker down here, and then and then your median ends up being, you know, your median could be there, or actually, you know, your median would probably be up here, but your mean might be down here.
Okay.
Okay? If you were looking at your mean, we don't put that on our box plot, but if you compared the mean to the data, we actually call that negatively skewed. We'll talk about skewing in a little bit, okay? Alright, so I'm going to give you a few minutes. I want you to try this one, and I'm actually going to stop the video and do a second part here because this may take a little while. Alright, so some of this is just interpreting, well actually all of this is kind of just interpreting things from this box plot, okay? So take a couple minutes here, find someone to work with, and see what you can do with it.